Okay, sure. So, good evening, everyone. Welcome to the third live session of the course Fundamentals of Additive Manufacturing Technologies. Any query in the chat box and we can discuss. Kirubakaran is typing. Good evening, Kirubakaran. Please feel free to type your doubts in the chat box. You can also give the feedback about the course. We can discuss if you have any doubt in any of the lecture. I can go there and I can explain it to you if you want. Okay, Kirubakaran is asking what is the difference between FDM and FFF. So fine, FDM is a commercial name. I think it was given by Stratasys, if I'm right. Not sure, but I think it was a commercial name. While FFF, which is stand for fused filament fabrication, is a more generic name accepted by the research community for the technology, which is particularly based on material extrusion, where wire is used as a raw material. So it's called fused filament fabrication. While FDM, which stands for fused deposition modeling, is more a commercial term given by someone. It may have a copyright issue. So it's recommended that when you use the term like triple F, you are being more generic and widely accepted in the research community. Okay, Kirubakaran is asking in FDM, lead screw provide excellent mechanical property. Then why we go with belt drive? The price, Kirubakaran, nothing else, I believe. The ball screw or lead screw are a bit expensive than the belt drive, and also if the size is high, then that is an issue. Now another thing is very importantly, you really do not want that accuracy because your layer height is what is going to dictate the accuracy of the part in Z direction, right? So if your layer height is bad, then why do we really worried about making a machine very accurate? Correct. If even if you are using ball screw, you cannot really reduce the layer thickness, right? And if you cannot really reduce the layer thickness, then what is the point in giving unnecessary very high accuracy in XY direction while you cannot maintain that accuracy in the Z direction? I hope I have answered your question. So there are two reasons for that. Are you able to follow me, Kirubakaran? Okay. Uh, Thank you, sir. Difference between all AM processes. Oh, is it a question? Like all AM processes you want me to explain here? That will be taking a lot of time, I guess. But uh, basic SLA, many type are available. Okay. Okay, because BCS may be for because. Okay. So I can explain about that. You might have remember the way we classify the uh, additive manufacturing machine or system was bit different than the conventional methodology followed in other books, right? We defined the each and every process, like for example, liquid based or liquid photopolymerization based additive manufacturing system based on different subsystems used in it, right? And they all have different capabilities. Like in SLA, you can use sharp laser, you can use flood laser also, you can use galvanometer to move the laser beam, or you can use mask based system, or you can use DLP based system, or you can move your head, that is called flying optics, or you can move your liquid tank, that is called as flying liquid. So there are so many options available, and each one has its own application and advantage. So what people do, they basically pick the desirable subsystem for a particular unit of the machine and then come up with a new machine, right? It may keep on adding also. So that is why you see a lot of variants in SLA as well. Okay, some people use sharp laser, some people use flood laser. If flood laser is used, then of course we cannot use galvanometer. That doesn't make any sense. So we have to go with DLP or mask based system. So that is why you see a lot of variant in the system, and that was true for all AM processes you might have seen. And I believe that one of the unique feature in our course was that we classified the AM process in a very different way, so that you can have that idea why these systems are having so many variants. I hope I have answered your question, Kirubakaran. Yes, Avinash. What is the exam start time on 30th October? Oh, okay. I'm not aware of the time. Just wait. We'll let you know in 2-3 minutes. But I think that you can confirm uh, on the website as well. Yes, Kirubakaran, you cannot speak here. Only I am allowed to speak. But yes, you can type whatever you want. And if you want to discuss, maybe again, you always have my email ID. We can discuss maybe on Teams sometimes if I when we'll find time. There you can also speak. So yes, Mr. Avinash Deshmukh, we are checking. If we find, we'll let you know. If not, then may not be. And please, Avinash, if you have other doubts, feel free to ask. We'll be very happy to discuss. Kiruba Karan is saying, why, sir, coating technology is not available in AM? Coating technology. I mean, you need to be a bit specific, Kiruba Karan. Are you saying there is no AM process which uses spray like thing, or coating is like vacuum coating and build the part? So there are processes. Again, if you try to classify it under the 7 processes which we have seen or by ASTM, not all. Okay, that may not fit anywhere, but you just be a little bit specific about which coating technology. And there are some research laboratory based systems available for coating also, which I know as far. Even like electroplating, that is not having really a very valid classification in ASTM. Those are not standard systems yet. They are still research going on. But what people do, they put mask and then do plating in an entire layer. Then they put mask where they don't want to deposit, and then again do the plating. They keep on doing it, the coating one over another, the basically not coating, plating, and then uh, fabricate the parts. Similarly, it can be done through coating as well. But yes, I don't think there is a commercial or uh, standard system accepted by ASTM so far and classified in their system based on coating technology. But it's not like there are not. There are a few, like I give you example of plating, or it could be others also. In MCQ, AM is based on object geometry, but the statement is AM is independent of object geometry. According to me, right now, additive manufacturing build parts irrespective of the shape of the geometry. So that is true, because even if you are building a cylinder, for example, right, in additive manufacturing machine, or you are building a cube, what do you need? You need nothing. You need the same thing. You need the same 3D printer. It will deposit in the same way, but not now in a circular manner, but in a cubical manner. But tooling will change in other machines. For example, you are trying to make a cylindrical object, maybe by extrusion, for example, then your die will be of circular shape. And if it is a rectangular or cubical, then your die will be of rectangular shape, the cross section of the die. So in other manufacturing processes, the tooling changes based on the shape of the geometry of the object. But AM, it doesn't happen like this in additive manufacturing. What happened in additive manufacturing? It just use the same machine, same tooling, and really does not bother about what shape right now it is having. So that should be the answer. The correct statement should be the additive manufacturing is independent of object's geometry. That's the correct answer. Okay, so I think Mr. Avinash, I got your answer. I think the exam is on 30th October 2022, morning 9 a.m. to 12 a.m. and evening 2 p.m. to 5 p.m. However, you should check the website very regularly if there are any changes, because that is what we know right now. That is what written on website right now. But you have to look into it carefully. Okay, so another question from Kirubakaran. To tensile test for filament, some may pure matrix filament, some may be composite filament, of course. ASTM standard you are giving for that. In composite journal, yeah, and this is used. I'm not getting this question. To tensile test for filament, ASTM 3039. Okay, you are telling about the specimen you prepared by ASTM. This particular standard is followed for making the samples, and in some journal they are writing another one. I'm not sure about this standard right now, frankly. I need to look into it, but I'm aware of some of the standards of ASTM where we prepare the dog bone samples for tensile strength testing, and there, if there's a difference in the standard, then it is mainly due to the size. The one may be the miniature, another could be the large scale size. That is what I think, but I need to check. I cannot comment what is the exact difference between these two standards. Yes, so how to select ASTM standard for tensile? It is already given. So that is what I'm saying. I need to check the difference between 3039 and 638. That difference I need to check, but you can use either one of them. That I'm very sure. And let me see if we can have a look into these two standards of tensile test, that is 3039 and 638. ASTM D3039 and ASTM D638. Just show me the difference between the sample size and shape. Yes. I will check that. What is the difference between these two? But I believe you can use any of them. We'll let you know the exact difference. I'm not sure. I have to look into the standard. I have to read that and come back to you. But the best practice is, yes, what you are following. You go, the best practice could be even you search for the good journals and follow what others are following, the other researchers are following. You can check, take the data from there as well. what ASTM standard they have used for tensile test, or you just directly go to ASTM and then search. That may take a lot of time, but the shortcut could be go to Google Scholar, search for good journals, find the uh, good papers, and you just try to find out the ASTM corresponding to their samples. Yes, so Kirubakaran, you're writing 250. That I believe is the length. 25 is the width, I believe, of the I think the gauge zone, and 5 is the thickness. Yeah. Mm-hmm. So for 3039, the size is different, I think, and the size is different for 638, I believe. Huh? Material also. Okay. One is for plastic, other one is for resin. Other one is for resin, nah? Other one is for composite. Composite. Okay. So as per ASTM, it is for plastic usually we use that standard, and for another one we use that standard. Then only it become apple to apple comparison. Kirubakaran, when you use the same specimen, exactly same dimension. However, theoretically, you can use any shape, right? Of course, it should have necking, it should have the gauge zone, but those ratios has to be maintained. Once you follow that in most of the materials, but after a rigorous analysis on how they get deformed, the deformability of different materials lead to the different dimension of the tensile sample size. Okay, so that is why I believe the plastic samples are different size, composite different, resin based different. How to control friction factor in FTM? Why do you want to control the friction factor? That it is the property of the liquefier, if I'm correct, and how you can control it. Uh, if you have a system, you may not have that freedom in your hand, controlling the friction factor. But if you are designing your own liquefier, yes, then you can look into the walls of the liquefier and check that, and you can control the friction factor, I believe. Also, what is the reduction ratio? You know that the length of the zone in which it is getting heated up, the zone it is further getting converged, those sections of the liquefier, you can nicely check and control the friction factor. But I believe, I'm not sure whether you are trying to design a liquefier or you are just using a 3D printer and there you are trying to reduce the friction factor. So I hope I have answered your question. So ASTM D3039 is for plastic and ASTM D638 is for resin based material, because and the size must be different, or some those dimensions should be different, and they are decided by the deforming behavior of these materials. Okay, if you have few more doubts, please feel free to write. I'll be very happy to answer. Okay, if there are no doubts, Okay, there is a question. What is the basic difference between SLA and SLS process? Okay. Okay. SLA is stereolithography apparatus. That is basically a liquid-based process. So the raw material is different. And in the case of SLS, the raw material is in the form of powder. Okay. Where they both use laser. The full form of SLS is selective laser sintering. This process, selective laser sintering, is used for powder to sinter the powder particles together. It could be plastic particles or it could be other particles also, but just to sinter, not melt. Okay, they both use liquid. Ah, Here, like in SLA, S stand for stereo, while in the SLA, the first S stands for selective. So there is a huge difference between these two. Maybe one common thing, SLA and SLS uses the galvanometer to deflect the laser beam. Mr. Avinash, did I answer your question? Okay. Yes, good. Thank you, Avinash. Okay. So any other doubts, please type, or if not, then all the best for the exam. It is on 30th of October, and not definitely if you have done the assignments with uh, I mean properly without taking any help of any of the friends or maybe some other source, just by watching the lectures. If you have done the assignments, then I'm very sure you will score good. That I can assure you. All the best for the exam once again. And if there are no more doubts, uh, I think we can stop here. So IIT Guwahati team, I think there are no more doubts of the candidates. Yeah. Sorry, Kirupakaran, what is the question? I'm not getting it. Short description needed for all AM processes. Yes, I mean, you want like a summary, just a final. It's a good idea. I think. Thanks for this suggestion. I think what I'm understanding, maybe next time what I'll do, uh, uniqueness for of all AM techniques. Maybe we'll prepare a next year, maybe a video we'll add in our lecture series, and where we'll summarize all the AM processes together in single video so that one can recall what they have learned in all lectures. And yes, it's a good idea. I think we'll think about it, Kirubakaran, maybe next year. It's a good feedback. Okay, so thank you. If you have any further doubts, please feel free to write to me. You already have my email ID. If time permits, I would love to interact with you over online platform also, if possible. Okay, if possible, kindly provide previous year question paper. That's not possible, Kirubagaran. That's not even good. You should not even look into that. It's a good practice. Okay. I'll not ask any question out of the syllabus, and you should not even search for such things on internet also, even if it is available. It's not a good practice. You should not appear in an exam just to pass, right? To test yourself, whatever how much you have learned. It's a not only your exam, it's my exam too, because I also see how many students are getting passed. That shows how much we have, how effort, I mean, how good our videos were. So should never ask for previous year question papers, huh? Let's not do it, and don't even search. I'll recommend you go with full practice. Just watch my videos and just solve the additive, the assignments. Nothing will be outside of that, and I'm very sure you'll do good. So let's not search for the previous year question papers. Okay, I think uh, yeah, thank you, Kirubakaran. There are no more doubts. We can stop the session here. Thank you. Please feel free to write me an email if you require, if it is required. Thank you very much. IIT Guwahati team may please end the session now.